Hi guys. Hope you're having a great day. Sorry that I can't be there with you. Wish that I could. But you get the next best thing, which is me teaching on the video. Woohoo! All right, so we are going back to periodic table. Yesterday we talked about the alkali metals. You took some notes, and hopefully you saw that group 1, except for hydrogen, were our alkali metal groups. So you should have lithium down to francium colored. So now we're going to talk about the other families, right? They got to have some things in common too. So just some reminders as you go through the video. Make sure you pause whenever you need to color in. Make sure you get all the right things colored. Also pause to take notes. And at the end of every class period, don't forget to fill out that Google form for me so I know how much you got done in class, and I can come back and check your work to make sure you did actually get it done. The Google form is for a grade, so don't forget. Do the Google form each day. All right, here we go. So the next thing we're going to talk about today is this second group right here, and we are going to call these guys our alkaline earth metals. They're awesome too, just like our alkali metals. And here's what you need to know. Don't forget, pause whenever you need to. Here's what you need to know about your alkaline earth metals. So in your notes, don't forget, go ahead and head your new part of your notes, alkaline earth metals, and you are going to write out these first 3 bullet points. That your alkaline earth metals are still really reactive, but they're not as reactive as your alkali metals. They are all solids at room temperature. They are also silvery and shiny, and they act like, or they're really good conductors of heat and electricity. For this last one, I want you to pick an alkaline earth metal. So if we go back, maybe beryllium or magnesium or calcium if you're really feeling good about your Bohr's models. And I want you to figure out how many valence electrons there are in those metals, or pick one of them. So draw one of those out underneath your alkaline earth metals. So just to show you how it goes, I've picked beryllium. So pause, see if you can draw beryllium, compare it to what you got, what I have here for you. So pause video. No, really, pause the video. Okay. Here is our beryllium atom. I've drawn my nucleus. Hopefully you know where to find the information for your nucleus. I'm more concerned about your electrons now. So I've got my shells. In my first shell, I can fit 2 cars, so they're both filled. And then on my outer shell, we have 2 electrons. So you've got 4 total electrons and 2 valence electrons on that outermost shell. So another thing to write down in your notes about your alkaline earth metals is that there are 2 valence electrons in every single one of your alkaline earth metals. So take that down in your notes. 2 valence electrons. When you're ready, you're going to pick another color. So pick another color. We're moving on to the next family group. So once you go back to your periodic table, we are going to talk about this giant behemoth of a group right here. So pause the video, make sure that you color in the right elements, because this is a tricky one. Don't go too far over. You're going to only color in these guys right here. We call this group our transition metals. Transition metals are going to be a little special. We'll talk about them in your notes. But this is kind of where you think of most of your metals, right? Silver, gold, copper, mercury. What? How's mercury? Had to, guys. Sorry. Iron. All of these guys. These are like what you think about when you think of metals. So pause, color, get ready for the notes. So now in your notes, these are the things that you're going to talk about. They're less reactive than other metal groups so far. They're really good conductors of heat and electricity, and they are malleable. In case you don't know what malleable means, it means that they can be bent into different shapes or made into sheets of metals. Kind of cool. We're not going to study much of these. This is going to be, like I've mentioned before, a chemistry topic, but they are important to know for our family groups on the periodic table. So, got a little bit of information about transition metals, and here we go to the next family group. Pick another color! Alright, This is another group called, we call these guys our other metals. So be really careful. Don't forget that your periodic table has different names for these guys, but look at your atomic numbers. So make sure you're coloring in the correct atomic numbers. So it's going to go from 113 all the way to 116. Those are your other metals down here at the bottom. Pause the video, color in your other metals. Now, this is what you need to know about our other metals. Not very much here. They're soft metals and they've got really low melting points. So think about this. Low melting points. Is that a physical property or a chemical property? What do we think? What do we think? Physical property is right because it can be measured. Can you measure the matter in some way? That's physical for sure. Oh, by the way. So, like I was saying, other metals have low melting points, a high density, and they can be found kind of along that step ladder. So pause the video, take your notes, and pick another color! All right, next one we're talking about are our semiconductors. So again, be careful, color in just the right elements here. So take your time coloring this guy because he's kind of crazy. And when you're ready, after you've colored, go to the next piece of notes in your notebook. So semiconductors, they conduct electricity only under certain conditions. They like certain environments. They are useful in electronics. Sometimes they act like metals, and sometimes they act like nonmetals. Another word for semiconductors are metalloids. Say it with me, metalloids. And they are also along the step ladder on our periodic table. So pause, take your notes, and we're moving on. Pick another color! All right, our nonmetals. So that's this little group right here. Be careful. Make sure you color the right ones in, and pause to color. Here's what you need to know about your nonmetals. Living things are a combination of all of these elements. So these guys are pretty special too. They are found at gases in room temperature. And don't forget hydrogen. Go color in hydrogen. He's a nonmetal. So make sure you go back into group 1 to color hydrogen in. And these guys are not good conductors. They are really good insulators. So take your notes, pause, and pick another color. All right. Another group we have are the halogens. And halogens are on this row 17 or 7A. We're going to come back to what that means later, so make sure you're paying attention. There's 2 different names for those groups. So pause, color, and here are the notes you need for halogens. These guys like to bond with our group 1 metals, and we're going to talk about what bonding entails later, but just know that they like to group up with our group 1 metals. They are more than likely going to be seen as compounds in nature, and compounds are just when it's more than one element combined. So they like to bond. They like to be together. I want you to think about it. How many electrons do you think that this group, or how many valence electrons does this group have? Draw it out. So here's our nucleus for chlorine, and I went ahead and drew it all out for you. So if you count how many valence electrons there are in chlorine, 1, 2, 3, 4, 5, 6, 7. So you're going to add this note into your notebook. Halogens have 7 valence electrons. One more time. Halogens have 7 valence electrons. So that's going to be important later. I just wanted to remind you of that. So pause, do whatever you need to do, and then you're going to pick another color. All right. Finally, over here, at the very end, we have our noble gases. So pause and color in our noble gases. And here are the notes that you need about noble gases. They are inert, which means stable. They are very unreactive. They're all found as gases at room temperature. Most of these gases are colorless and odorless. And let's maybe see what our valence electron count is for these guys. Take a guess. What do you think? Any ideas?